Hello students, I Dr. Rekha Mithal from Department of Chemistry of JECRC College. Today we'll discuss about the topic organic reaction mechanism. So first of all we should know about what is organic reaction. An organic reaction is a change in a structure or functional group leading to the formation of new substance. The compound undergoing change in a structure or functional group is called a reactant or a substrate. So in other words we can say that organic reaction is that process in which the reactant is converted into product. Organic reaction, it is of four types. First is substitution reaction, second is addition reaction, third is elimination reaction, and the fourth one is rearrangement reaction. So first of all we'll discuss about the substitution reaction. Now substitution reaction is what? The reaction in which the displacement of an atom or a group by another atom or a group takes place. Like in this reaction, the methane react with chlorine and it forms the methyl chloride and HCl. So here the substitution takes place. The hydrogen substitute with the chlorine and in this way a new compound is formed. Now the substitution reaction also takes place in three ways, that is either by nucleophilic substitution reaction, second by electrophilic substitution reaction, and third by free radical substitution reaction. In nucleophilic substitution reaction, nucleophile is involved in the reaction and that's why it is called nucleophilic substitution reaction. Nucleophile is electron-rich species, so that electron-rich species will attack on the electron-deficient species and it forms a new molecule, new product. In case of electrophilic substitution reaction, electrophile is used. Electrophile is electron-deficient species, and since it is electron-deficient species, so it will attack on the electron-rich species and form a new compound, form a new product. And in case of free radical substitution reaction, the substitution takes place by free radicals. So first of all the free radicals are formed, and then these free radicals, different free radicals combine together and it forms a final product, the new product. So first we'll discuss about the nucleophilic substitution reaction. In nucleophilic substitution reaction, which is also of two types, that is SN1 reaction and second is SN2 reaction. So this is SN1 reaction, nucleophilic substitution unimolecular reaction. In this case, the nucleophile will attack on the compound, that is the reactant, and since it is electron-rich species, so that electron-rich species will attack on the carbocation and it form the new product. This SN1 reaction, that is the substitution nucleophilic unimolecular reaction, it is two-step reaction. In this case, like in this reaction, the tertiary alkyl halide react with the nucleophile, and this nucleophile results when it attack on the tertiary alkyl halide, then it form tertiary alcohol and halide ion. So how this reaction takes place, it is represented in this. This OH is hydroxyl ion, that is nucleophile, electron-rich species, that is the nucleophile, and this bromide ion is the halide ion. Bromide ion is the leaving group. From the reaction which we have seen in the previous slide, we can explain that SN1 reaction is two-step process and it leads to the formation of carbocation intermediate. In the first step, polarization and cleaving of CX bond occur to form carbocation intermediate. The first step is reversible process. It is also rate determining step of the reaction. And in the second step, the nucleophile will attack on the carbocation to form the respective product. So this is the first step in which the carbocation is formed, and in the second step the nucleophile will attack on this carbocation and it forms the final product. So in this way, this SN1 mechanism is two-step process in which the intermediate is formed, that is the carbocation is formed, and then after attacking the nucleophile to form the final product. The planous nature of carbocation results in both inversion and retention configuration. Now we'll discuss about the SN2 mechanism, that is substitution nucleophilic bimolecular reaction. In this step, this mechanism is second order kinetic, and the rate determining step depends on both the concentration of alkyl halide and the nucleophile present in the reaction. The SN2 reaction is one-step process and there is no formation of intermediate. So in this case, intermediate does not form, only as the nucleophile will attack on the carbocation and it forms the final product. There is no intermediate. Only the transition state is formed, which is represented in this mechanism. But this transition state, the middle compound, that is this is the transition state, which is very unstable, and since carbon is attached with 5 atoms, which is it's impossible because carbon is having the 4 valency, so it immediately converted into the final product. So this is the mechanism, and final product is formed. This transition state is unstable, so final product is formed. This reaction is one-step process, unlike SN1 reaction. In this reaction, there is no formation of intermediate, as I told you. The reaction undergoes a transition state where the nucleophile are attached to the alkyl halide, and hence it is very clear the rate determining step is dependent on the concentration as well as the nucleophile. However, the transition state is highly unstable because in the transition state carbon is bonded to 5 atoms. So this is because there is simultaneous breaking of carbon-chlorine bond and formation of carbon hydroxyl bond takes place. And in this step, the nucleophile attack the alkyl halide substrate in the back side, and it forms the inversion form of the product. Now the second type reaction is electrophilic substitution reaction. In electrophilic substitution reaction, electrophile are involved. Electrophile, that is electron deficient species. Since it is electron deficient species, so it will attack on the electron rich part of the molecule. This is the general reaction. Here E represent the electrophile, and this the final product, that is Ry, is the molecule reactant on which the electrophile will attack and it forms the final product. So this is the general reaction. An example of electrophilic substitution reaction is given, that is the aromatic halogenation, and this the benzene react with the bromine and it forms this new compound. In the above reaction, a bromine atom substitutes for a hydrogen atom. Electrophilic aliphatic substitution are relatively uncommon. So in this the difference between the nucleophilic substitution reaction and electrophilic substitution reaction is that in electrophilic substitution reaction, nucleophile are involved, that is electron rich species is involved, and in electrophilic substitution reaction, electrophile, that is electron diffusion species are involved. The third type substitution reaction is free radical substitution reaction, in which the free radicals, first the free radicals are formed, and then these free radicals combine together and form the final product, a new product. So it is basically depends on the chain mechanism. There are three steps, and the first step is initiation step, second is chain propagation step, and third one is chain termination step. So what happened in the chain initiation step? In the chain initiation step, the free radicals are formed as it is in the reaction. So free radicals are formed. Chain propagation step. In chain propagation step, more free radicals are formed. That is the methane that combined, that react with the free radical of chlorine, and it forms the free radical of methane. And in this way, different free radicals are formed. And finally, chlorine radical, methyl radical, different radicals are formed. And in chain termination step, termination means now the reaction completes, and in this reaction, in this step, the recombination of free radicals takes place, and it forms the final product as it is represented in the reaction. So the last possibility, the termination step, will result in an impurity in the final mixture. Notably, this results in an organic molecule with a longer carbon chain than the reactant. So sometimes it happens that the longer carbon chain is formed in the product as compared to the reactant. So this is the final reaction for the free radical substitution reaction. So this is all about the substitution reaction. Thank you, all of you.